Sometimes instead of just going out, doing a survey, and seeing what kind of confidence interval you end up with, you want to be a little bit more careful when you start. You want to select the sample size that is appropriate to give you the right confidence interval that you would want at your given level of confidence. So we're going to take a look at how to do that. Your goal is to find the smallest sample that you can collect data from to have some percent confidence interval with a margin of error of plus or minus some percent. And in order to do that, you use this big ugly formula. We're going to talk through each part of it step by step, so it should make sense by the time we get through it. Very first part in the corner here is something called Z-star. This takes the place of whatever confidence level you're going after. Now, Z-star is going to most commonly be in place of 90, 95, and 99% confidence levels. And so for each of those, it has some value. Now, I don't expect you to memorize these. This is something that you would write down and reference. It will be referenced on any sheet that you would need to take assessments or homework with. So these are critical values, and if you're curious where they come from, it's related to the normal curve. So we can do a quick example here. If we go to second vars, bring up our distributions, and bring up our normal CDF, if we take the area under the normal curve between negative Z-star and Z-star, so negative 1.645 and 1.645, you're going to find that the area under the curve is almost exactly 90%, or 0.9. Same thing if we did that for 1.96, we would get 0.95 for the area, and then same thing here, 2.576 would give us 0.99 as the area under the normal curve. So that's where these values come from. We take that term and square it, by the way. Next part is something called P-star. And this is going to seem a little bit ridiculous at first, but you'll understand it as we use it more. P-star is a guess at the population proportion. It's a guess. So you use data from a preliminary study if you have one. So if you have a small study that says, oh, about 60% of people are going to say this, then you use 0.6 as your P-star. Now, if you have no idea, just use 0.5. The whole trick to P-star is that if you have something where you know it's going to be like 90-10, you can actually end up getting away with a smaller sample size than if it was 50-50 when you multiply these numbers out. So unless you're pretty darn sure that you have some data that supports it not being 50-50, just use 0.5 as your value for P-star, and you just plug that in. Your margin of error in the bottom, that margin down there, it's how much error, percentage error, that you're willing to have. And then you would rewrite that as a decimal. So if you're willing to have up to 3% error in either direction, your margin of error down here would be written as 0.03. And again, that term also gets squared. And then finally, the result of all of this is your sample size. It's the smallest your sample can be while staying within your margin of error. One thing to consider about that is that you need to always round up. Even if you were to get like 112.2, you would round it up to 113. And the reason is that if you rounded down and you did your normal calculations, you would find that your margin of error was a little bit bigger than what you had originally said it could not be bigger than. So always round your sample size up. Never hurts to have too many people, but it can be dangerous to have too few. So let's apply this to an example. You want to know what proportion of Americans go to a Friday fish fry at least once each year. More specifically, you want to be 95% confident in your result within a margin of error less than plus or minus 3%. Well, that's pretty specific. So let's go ahead and see what we can do. First thing we can look at is Z-star. It says 95% confident in your result. So 95% confidence means a z-star of 1.960. So we plug that in. Then we have our p-star. We don't have any preliminary data in here, anything that suggests what they think the proportion might be. So we're just going to go with our safe bet of 0.5. We'll plug that in for both of our p-stars. So we want a margin of error less than plus or minus 3%. So we're going to plug in 0.03 as our margin of error down there. And then when we plug this all into our calculator here, we have to be careful with our parentheses and whatnot, but we're going to get 1.96, and we'll leave off the 0, squared times 0.5 times 1 minus 0.5, and that's all going to be divided by our 0.03 squared. Oops, make sure you get the right symbol in there, or that'll get you in trouble. And once you got that in there, you get your result. So I'll leave that up here for just a sec. We end up getting 1067.111, and we always have to remember we have to round up that value. Even though it's 0.111, we always round up. So that's going to end up being 1,068 people. One thing you'll find is that a 95% confidence plus or minus 3% is a pretty standard thing that's reported in a lot of like newspaper surveys or official polls. So most polls tend to sample a little over 1,000 people in order to achieve that. Next example, you want to know what proportion of BHS students want to join a new unicycling club. Preliminary studies showed about 30%, and you want to be 90% confident in your result with a margin of error less than plus or minus 4%. So let's go ahead and start again with our confidence level. It says 90% confident. That's a z-star of 1.645. So we plug that in. P-star this time, we actually do have a data value. It says preliminary studies showed about 30%. So that means our p-star, we're going to use 0.3 instead of 0.5. So that'll allow us to get a slightly smaller sample because of that. Our margin of error says less than plus or minus 4%. So that's going to be 0.04 going down there. And then if we plug this into our calculator, which I will allow you to do on your own, you're going to end up getting 355.166. We of course have to round up, so that gives us 356 as our sample size. So that's how you find the sample size of a set of data.